Okay, in section 10.3.5, review and preview problems. Problem 173. From a new shipment of 100 video games, how many ways can 3 games be tested to see if they are defective? Okay, so there's 2 different ways I could think to solve this problem. One is this a permutation or a combination? Well, first of all, can there be repeats? No. We're going to choose 3 separate games to test. Does the order matter? Also, no. The order does not matter. We're just choosing 3 and we're going to test them in any order. So this is a combination. So one way we could solve this is by using the equation for a combination. We have 100 video games and we're choosing 3 of them. So we could use our equation, that's 100 factorial over 100 minus 3 factorial, which would be 97 factorial, also divided by 3 factorial. Okay, so let's see. If I simplify this, I'm going to have 100 times 99 times 98. That has, I've factored or simplified all the 97 down to 100 to cancel those out. And I'm left with 3 times 2 times 1. Okay, and before I put this in my calculator, I could put it right in, but I could divide that 3 into 99. I could divide 2 into 100. 50 times 33 times 98, I get 161,700 as my number. What's a different way that I could do this? Well, let's just, using a decision tree would be tricky unless we divide. I think using the combination format is probably the easiest format, or easiest way to solve that problem. Okay, let's look at problem 74. Which is greater, 5 minus 2 factorial or 5 minus 3 factorial? Justify your answer. Okay, well, 5 minus 2 is just 3 factorial, and 5 minus 3 is 2 factorial. These are small enough we can actually calculate these. 3 factorial, remember, is 3 times 2 times 1, which is 6. And 2 factorial is 2 times 1, which is 2. So which is bigger? 3 factorial, which is 5 minus 2 factorial. And I think if you calculated those out, that would be sufficient justification. All right, problem 175. Write an equivalent expression for each of the following situations that does not include the factorial symbol. Okay, so n minus 3 factorial. They want the first 5 factors. Well, the first one is n minus 3. And then the next one is 1 less than that, which is going to be n minus 4. And then n minus 5. And then n minus 6. And the last one, n minus 7. Those would be the first 5 factors of n minus 3 factorial, right? Because n minus 3 factorial is just multiplying wherever was our starting point all the numbers down to 1. Okay, how about the first factorials of n plus 2? Okay, we're starting there. What's 1 less than that? Well, n plus 1. And 1 less than that is just n, and then n minus 1, and then n minus 2. Okay, let's see, n factorial over n minus 3 factorial. Okay, well, let's just think. Okay, n factorial is n times n minus 1 times n minus 2 times n minus 3 times n minus 4, all the way down. And n minus 3 factorial is n minus 3 factorial times n minus 4 factorial, all the way down. So these cancel, and everything down here is all going to cancel until we're just left with n times n minus 1 times n minus 2. All right, in part D, n plus 2 factorial. Okay, so let's write this out. We have n plus 2 times n plus 1 times n minus 1 times n minus 2 times n minus 3, all the way down to 1. And n minus 2 is going to be n minus 2 times n minus 3, all the way down to 1. And look, these cancel and those cancel, and everything's going to cancel all the way down, and I'm just left with those first 4 factors. N plus 2 times n plus 1 times n minus 1. All right, problem 176. Of the students who choose to live on campus at Coastal College, 10% are seniors. The most desirable dorm rooms are in the newly constructed Ocean View dorm, and 60% of the seniors live there, while 20% of the rest of the students live there. Represent these probabilities in a two-way table. Okay, so let's make our table here. Here we have students that live in Ocean View and people that live everywhere else. And let's say this is seniors, and this is not seniors. And they don't give us numbers, right? They just give us percents. So we're also going to add some totals here. They tell us that 10% are seniors. Okay, so that's this column, this first column. The total is 0.10. That's 10%. And the 60% of seniors live in Ocean View. That's a little bit tricky. We'll come back to that. And 20% of the rest of the students live there. Okay, so Ocean View seniors. So this is the box we're interested in filling out. 60% of seniors live there. So do I just put, let's see, 0.6 there? Well, that's kind of tricky. 60% is, 0.6 is bigger than 0.1. It's not 60% of all the students, it's 60% of seniors. Okay, so that's not right. I need to multiply 60% of, which means multiply, seniors. So 0.6 times 0.1 gives me 0.06. That's my value for that box. Okay, and 20% of the rest of the seniors, of not seniors, live there. Well, one thing I do know is that this is a 1, right? And remember, all my columns and rows need to add together. So if this is 0.1, what's this? 0.9. So to find this box, whoops, oh, did not want that to be black. To find this box, I'm going to use 0.9 times 0.2. That's 20% of all the rest of the students. So that's going to be 0.18. All right. Now I've got to fill in the rest of my box, right? What goes here for seniors and other housing? Well, 0.06 plus something is 0.1, so that's going to be 0.04. And here, 0.18 plus something is going to be 0.9. That's going to be 0.72. If I add up 0.06 and 0.18, I get 0.24. And if I add up 0.04 and 0.72, I get 0.76. Okay, I'll be honest, that's a pretty complicated table to fill in. The key was these two entries, right? Remembering we needed to multiply them together. Okay, so now we can answer the questions. What is the probability that a randomly selected resident of the Ocean View dorm is a senior? Okay, so this is conditional probability. We only care about these guys, the Ocean View dorm here, okay? So our bottom number of our conditional probability is 0.10. Of those students, how many are seniors? 0.06. And if we put that in our calculator, we get 0.25 or 25% chance that the student is, if we know that they live in Ocean View, oh, sorry, you know what? I did that wrong. Forgive me. We know they live in Ocean View, so I highlighted the wrong thing. We want that row right there. The bottom number is going to be 0.24, and the top number of those, how many are seniors? 0.06. Now this is where we get 25%. All right, last question here. Is this associated? They ask us specifically, use the alternative definition of independence, you could look right here, to determine if being a senior is associated with living in the Ocean View dorm. So if that was true, the probability of being a senior times the probability of living in Ocean View would be the probability of being a senior and living in Ocean View. What's the probability of being a senior? 0.10. It's that number right there. The probability of living in Ocean View is 0.24. That number right there. What's the probability of being a senior and living in Ocean View? That right there, 0.06. Are they equal? No. This is 0.24. This is 0.024. That is not equal to 0.06. They are associated because they are not independent.